We have another syntax, another command in SQL that allows us to do just that, right? To get around some of the limitations that group by introduces, right? So the having clause allows us to just do just that. Allow us to have aggregate functions in the where clause, right? So that we can say, hey, give me all the sections that have whose number of A's are equal to the maximum number of A's that are given to that section, right? So the generic syntax is that you can have aggregate functions not only in the select clause that we already know that group by allows us to do that, right? But the having allows you to also add aggregate functions in the where clause, right? So let's look at a couple examples. So say here we have several orders. We have Boone, Nielsen, Jensen, with different orders, and here we can see an example that we are using the summation of the order price, right, in the where clause, right, where after the group by we can identify and filter out which ones in the group by after having grouped. We can run an aggregation and then do the select to retrieve the fields that we need. Same thing though, in the select we still can only have the fields that are grouped by and they are aggregates, right? But at least we can now have aggregates in the where clause, right? So we could implement that limitation we found earlier. Here's a couple other examples where here's the where clause of I want to group by customer and add and only return those order prices that add up to something bigger than $1,500, right? So the grouping happened. After the grouping happened, I can now do a where clause on that grouping, right? And then so the first where happens first, then the grouping, and then another where happens. So it's kind of like a second time where clause, right? That allows us to filter out, right, the results of having grouped, and it gets around the limitation of the group by, because group by happens after the where and loses all those fields.